Okay, so let's start with the APP protocol design. I think everyone have joined, right? Okay, so can anyone tell me what are the different phases available in the APP?
It's idle phase, setup phase, and access phase.
Okay, in ideal phase means what is the status? Or what is the setup phase status? What is the access phase?
So in idle, if the select line or p select is zero, then we say and p ready is zero, we say it is in idle state.
Mm-hmm.
If if select line p select is equal to one,
Mm-hmm.
and data line, address line, and all those are valid uh, signals,
Yes.
then we say it is in setup phase.
Mm-hmm.
So if p enable is 1 and p ready is also 1, then we say it is in access phase. But with address line, write line, and data line, that should remain constant as same as setup phase. It
Mm-hmm.
should not change.
Yes, correct. So, as she explained, we have all gone through this information from the APP spec itself. So, we have the different phases, right? So, we have taken an enum for that, for the all the different phases which we have: idle phase, setup phase, access phase, and wait phase. And then these enum, we have just declared the handle of it like as a state, so that we can use in our always block to pass from which state we are, the to track that we have taken this FSM. So we have an FSM where we are trying, and before that we have written like the positive clock, P clock and negative P reset. If there is no P reset, then our present state will be idle. Otherwise, our present state will be the traversing to the next state. This is the basic logic in the reset state, what should happen. Otherwise, if it's not in reset state, what should happen has been declared in this piece of code. Then we have something called always at the rate star. Here we have something related to the FSM, which we have observed in our protocol spec. So the same thing, whatever they have showed us in the waveform or in the description, we are converting that exactly in terms of the code. So you can also try to do the design and try to create a test bench of that in the Verilog. And also you can do that if you are like I know already the Verilog things, then just directly copy paste this design which I am providing, and your main focus is to learn related to the UVM and SV, right? So you can just copy paste this design and work on the different components and this thing. But before going to that, at least we need to understand, right? Some might not understand, that's why I'm explaining. So we have taken something called case as present state, and if it is an idle, as these all are nothing but the whatever conditions are mentioned in the protocol. So if p select is high, it means that at the next part it can go to the second setup, right? So the next state will be setup only if the p select is high. Otherwise, it has to be going to the ideal part, because when the P select is zero, is nothing but in the ideal phase only the P select will be zero. So that's why in the else part we have mentioned this way. So now, if it has come to the setup state, and in that case, what are the different possibilities it can go to the either to the access phase or the wait phase or to the ideal phase? What are the different conditions we have? Those things we will observe. And so in the setup phase, if P enable is high, the next state is access. Otherwise, the next state is setup, right? And for the access phase, if P ready, in access phase, the P ready also comes into the picture, right? The slave is ready, then only it can be able to accept the data which has been sent by the master. So if P ready is high and if there is no P select, then the next state will be ideal itself. Otherwise, the next state will be the setup state, okay? Otherwise, the next state will be the wait. This wait is nothing but the wait states feature is there, right? For that, this is the part of the design which will execute that wait state. So now in the wait state, what it will wait for is the P ready. If the P ready is there, then the next state will be access itself. Otherwise, the next state will be the wait state. Means there won't be any transfer accepted because the P slave is not ready. That's why it will be moved to the wait state. Once the P ready is getting high, at that point it will accept the data. So that's why this is something called with wait states. Okay. And then we have written something logic for to write the data from into the memory and read the data from the memory. That logic also we need to implement, right? So that one we have taken it over here. When if it is p reset is low means it's in a reset state now, so the PR data will be 0. So there won't be any output data generated. So if it is not, then if P write means what is that? We are trying to achieve the write transfer. If you want to achieve the write transfer, you have to write the data. You have to put the data inside the memory, right? So you will have to check the valid signal for that. So you will write if P write is high, then you are putting the P write data into the memory. And if it is low, it means nothing but a retransfer. You want to fetch the data from the memory which was written by the master. So basically what master has written the data into the memory, that data the slave has to read from that, right? So how will it read? Based on the address. So the master will provide an address to write the data. With the same address it will fetch. If you it wants to fetch the same data, it has to give the address. So through that address it will find a appropriate data and it will fetch. And all these things, whether these things are happening properly, whatever data we are writing. Sorry. So whatever data we are writing is the data what we are getting is all happening properly according to our design is or not is what we will do with our by verifying through our UVM test bench. Is it clear for everyone regarding the design or any part of the code you haven't understood? You can ask me.
Ma'am, why did you commented that if state equal to, I mean, current state equal to access state?
Actually, your
That can,
voice is very low. Always, I really struggle to understand.
ma'am, that one, ma'am.
Line number you
Why,
can mention.
can you scroll down, ma'am?
Yeah.
Yeah, you have commented 65th line, ma'am. Why
Yes,
you
yes.
have at that part I didn't understand. Why have you commented, ma'am? In access state only, we have to done operations, ma'am. I
Yes.
mean,
But in the
yeah.
access state only we have to, but the problem was happening with the access state condition is that it was not there was some case where it is not going to the access, but still the operation had to be done. There was some case that way. That is why we had to comment, and even this way the things are working because when it there was some issue. I don't remember exactly what was the issue, but the actual design has to be this way. Means if the p write is there, then only this will happen, right? The p write will be high only if it is going into the setup phase, and then only we will if the p enable is high, then only the it will enter into that valid p write condition. Otherwise it is not going to happen that way, right? So that's why we have removed that.
Okay, ma'am.
Hmm. Anyone else? But if it is for any Verilog test bench, if you're trying, then you can add that. But for this UVM test bench, without this, it was working.
In
Okay, ma'am.
78 and 79th line, force release, are those keywords, man?
Yeah, means basically you are trying to actually this is not a recommended way to do in any of the industry projects, but here we are doing just we are trying. You can even randomize the P ready also, but here we are not doing that way. Here we are just giving like when you are forcing is nothing but if you are giving P ready as 0 and force means you are telling that P ready signal to go to 0 level for some duration, whatever duration you have mentioned. Release in the sense, whatever condition you are giving, right? 0 means if you release it, it will go to the P ready as high because we have already give the P ready as 1, right? So you are releasing whatever condition you are giving it. So these are the keywords from the Verilog itself. In
So
Verilog, we
this
have
is
both
for the
templates.
wait condition, right? Like we are
Mm.
forcing P ready to 0 and releasing P ready that is for a wait state, right?
Yeah, correct. To observe the wait state. Or even if we always give P ready as high, then there won't be the wait state condition, right? Because already the P ready is high. Where as soon as data has come, the data will be accepted, right? So in order to exercise the wait state, we have taken that. Okay. Anyone else have any queries? Okay, then we can
Ma'am,
move to the yeah.
ma'am, at line number 78 and 79,
Mm-hmm.
there is written duration of 300 nanosecond and 30 time duration. So about how much it will take to force to be ready at zero
See, this
condition?
is just to in my user way. You can even give 500, 600, whatever. Just I want to observe if P ready is not high, how my things will behave. Where the wait state scenario is there, right? Related to that, this is. So there is no hard fast rule that you have to give 300 itself, or you
No,
can
no,
even.
ma'am, my question was that at 300, after 300, uh, force will work at P ready 0,
Hmm.
and after 30, it will release the P ready.
Yeah.
So how it will work?
You
First 300
you
and
yourself
30.
answered your question, right? You said P ready will be high initially, and after 300 nanosecond, the P ready is posed to 0, and after that 30 seconds, P ready will be released to its whatever state it was there. In your question itself, the answer is there.
Okay, okay.
Hmm. Yeah, let's look at the APB interface. Okay. Give me a minute. Yeah. So now it comes to the APB interface. In APB interface, we have already discussed, right? In interface, we provide all the different signals which we want to use, and we will also declare some mod ports and the different clocking blocks. So this is the interface coding is done for this APB. So in APB, whatever signals we require, for example, P select, P enable, P address, P write, all these signals we have declared as logic. Why we have declared as logic? Because the same signal can be output to the driver, and some signals, the same signal can be also the input to the monitor. So to avoid the confusion, to declare it as an input or output, so they have declared them as a logic, and based on your requirement in the as the master is driving the data, right? When it is driving the data, this P address, P write data, P write, P enable, P select, all these signals will be driving from master to the slave. It is nothing but the output from the master, and it will be an input to the slave. So that's why in the master clocking block we have taken all this as an outputs, and whatever data from the slave we will get, right? So here the slave we have already we have a design for. Here we are implementing the entire coding for the APB master, right? So here we have a clocking block for master, and this PR data P slave P ready will be coming from the slave, right? So that's why it's an input to this master. Is it clear for everyone why they are called as outputs and why they are called as inputs?
Yes,
Yes.
yes.
And monitor everything will be input, because we are trying to capture the data and observe the different functionality that has been done by the different signals on whatever basis we have derived, right? So that's why if, for monitor everything will be the input. We want to capture the data whatever the signals have, and we want to share it to the other components for the further analysis. Either it could be a coverage collector to track the coverage information, or it could be a scoreboard to track the expected and actual data comparison, and whatever it could be. So that's why every signal is an input to the monitor. But in driver, it's not so. And we have something called this default queues also. Yesterday we have discussed, if we have mentioned the input queue is nothing but is the number of nanoseconds that will be after POSIX, how many actual nanoseconds it will start driving, and the output queue is nothing but after how many clock cycles, before the how many clock cycle it will sample it. So these things are nothing but here we haven't mentioned any clocking block default thing. So if you don't mention, it will refer to the default things. If you want to override those, you can just override them with some either #1 #0 based on your requirement if it is required. If you are facing some synchronization issues, then based on that you can change it. Okay. Basically, this clocking blocks, you also know that it also avoids our race conditions in the system Verilog you would have gone through. Like in Verilog, like how we have different regions where they're using non-blocking, all this we avoid the race condition. In system Verilog, we avoid it through program block, clocking blocks, all this. So you all know about this clocking block, right? So I need not explain in much deeper way. In this mod put is nothing but gives the directions, and the clocking block is for the synchronization, and these are the signals. And in the interface, if you want to pass any signal at the argument, that you can pass it. Like here we have passed the P clock. So this is the basic understanding of the interface coding. Then let's move to the top level module. So where exactly we have the that so far we had discussed, right? Like we will be using the interface to connect the DUT and test bench, all that. So for that, those connections, everything will be resided inside this test bench. So we need to include the UVM macros and UVM. We need to import the UVM package. Don't forget this, because rest all you might know, but you are new to the UVM. So these things are mandatory, because through this only we will fetch all the UVM. We all know that we use all the UVM library things. So without this, it will not work. So that's why you have to include this UVM macros, and you have to import the UVM package. And then you have to, whatever things you want to have to include in the test bench, those things. Like for example, the interface and the APB test has to be included in the test bench. And inside this module, the clock generation and the interface instantiation, all this, the DUT instantiation will be done here. You will connect the interface, all the signals to the interface, whatever, and clock generation. And also, if you want to check the waveforms, that is related to this here. The dump file app.pcd. If you include this only, you will be able to check the waveform. And then this is something the reset generation logic which we have written. And this config DB I have commented for now, because we are only concentrating about the skeletal part, right? So that's why I have commented this config DB code. And so this is the run test. We all know the run test will be there inside an initial block inside the test bench, where the actual when we invoke this run test only, the root component gets created, and then the build phase. This flow everyone by now you would have understood, right? So just go through like how the instantiation has been done here, like this slave signals, how they are connected to the interface signals. So all these things you can just go through, like whatever here interface is there, right? The APB interface. For that, we have taken instance, because if you want to use the interface, you have to take the instance of that interface, right? And as we are passing the argument as a clock, here whatever clock you are using, that clock you will pass, and then you will connect the different things here. So this is how you will simply code the test bench part, okay? And don't forget to include the interface and the test files here, okay? And then let's go to the, then what do you want me to explain the APB? Let's start with the APB transaction. So in the APB transaction is nothing but here I haven't mentioned anything related to the signals or anything. Just we are creating the skeletal, and we should make sure that we are not violating any of the macros by mistakenly using the object macro inside a component, the component macro inside a object, all these things we will be doing, right? So first we should make sure that everything, all those things are clear in our basic coding, because if you clear all this, when you go to the functionality coding, you need not worry about all this. Getting such kind of silly errors at the later part, it's always better to, this is my approach of doing it, all depends how others do, I don't know. But in my approach of doing is to create a skeletal first, and I want to have a nullify all my syntax errors related to the UVM macros, all this, because you guys are very new to this UVM. So there is more chances to make a mistakes, right? That's why first clear all those things and then only you start with the coding part. Okay. So now let me run this code and show you. Okay. So can anyone tell me what is this error? Why we are getting this error? Is everyone there? Just guess like what could be this error?
Maybe missing of UVM package.
We have done right already. We just have
Test
gone
bench line 3.
some wrong path to the file. What wrong path could be?
Test bench line 3.
Yeah, test bench line 3, fine. We have just UVM macros.svh, and we have also included the package. What else could be? Anyone can guess? Actually, I wantedly made this error so that everyone at your end you will not face.
So first we need to include the package in the macros, right?
No,
Not sure.
there is nothing like that.
There is nothing like that.
Ma'am, it's not searching that path of directory UVM macros dot svh. I think it's sc extension dot sv.
It's
Or
SVH.
else, or else in the option we need to select UVM.
Yes.
Can you
Yes.
We have to give the UVM 1.0 or whatever. Otherwise, this is not, these are related to some UVM macros, UVM package, right? So this will not have those information. That's why it will give us error saying that we cannot find something like this, all this. So most of the people do this mistake. That's why I wantedly did, and I wanted to show all of you. You make sure that you always select everything related to which you are coding. For example, you are trying to code for system verilog, you can mention that. If it is for UVM, you mention that. And also select a proper tool, and also click on EP wave. Right now you don't need, because now we haven't coded anything, right? So we will not get anything over here. But actually, if it is, then if you want to observe anything, you have to checklist this open EP wave after run. So this things, so also don't forget to do here in the test bench we have, right, this dump.pcd. This also you don't forget to do. You have to mention this. And give me a second. Let's now let me rerun the code. Okay. Now let's see if there are any errors. Now we are unable to end the simulation. Okay. So what could be the issue? Why it is unable to end the simulation? we have to debug, right?
We have to use $finish.
Okay. Even before that also we had done that, right? And it was working fine, right? Even without $finish.
So what is the error?
Yeah, let's see that. So it's for running for some time and it's giving us that maximum runtime has reached. And let's see, is it giving us any error? It's not giving us any error. But still it is just stuck. Why? What could be? Some warning is there. The simulator might be hung due to an infinite loop.
In driver, it is showing the infinite loop.
Yes. Right. So what could be? When it usually
This forever
which
begin.
clock it goes into then yeah.
Line number 16.
Yeah, so when you get some hint like this, right, like infinite loop, all this, so then you have to see like, are we missing something? Are we missing some logic related to those? It is related to which kind of block? So infinite means usually it could be some forever. That way you can just give. Okay, so right now we are not mentioning any logic here, right? So we can comment this also. So these kind of things. You should be careful with. I know now there won't be an issue. I did it so that you guys will know like that kind of errors you will get. Now it comes to the agent. Inside agent, we have all the transaction sequencer, sequence driver, monitor, right? So in that case, we have to include all those inside the agent. And inside agent, what you will do, whatever driver monitor sequencer, we have to just give the handle of it. You have to do the function. I am trying to do like this is the we have already discussed, right? We can have the different kinds of agents, active agent, passive agent, right? So if it is an active agent, only these two has to monitor. These three has to be created. If it is no passive, only monitor has to be created, right? So that part of logic I have implemented in the build phase. So I am providing the configuration capacity to the my master agent, saying that whether it wants to be active or passive, we can decide it. Okay. So whether you want to make it active or passive also, you can set through the config DB, like saying that this you want to make it as active, this you want to make it as passive. If you don't mention anything, it will be by default active only. So it will create. If you want to override it, you can do it. So these things you once after you learning the config DB concept, you can just try to explore and try to do the experiments also. And then it comes to driver. We all know what is virtual interfaces. Why do we need the virtual interface? And driver is a component, has to be extended from its base class, all these things, right? So the build phase, nothing I have done in driver, there is nothing to create, right? So in the build phase will be, we haven't done anything. In the run phase, actually the driver has a basic run phase logic, everything, driver logic inside the run phase. But for just for skeletal part, we haven't done anything in that. In the monitor, all these things also are not needed now for the skeletal part. You guys can ignore if you are referring this to create the skeletal. Now only the skeletal part means only the structure we want to try implement the connect phase. Now the UVM info, don't use the dollar display anymore in the UVM, at least they use the UVM infos to get the any for debugging purpose. So just make a habit of this so that you can use the verbosity, whatever features it gives by the UVM verbosity, those things like to filter the messages and all. Based on this, you can change, right, the verbosity level. So better if you use dollar display, you cannot do that. You have to go comment all that you have to do. So that's why start making the use of the UVM info. So this is what there in the UVM monitor. Okay. And then the sequencer, it is very simple. Just even with the actual code also, the sequencer logic is simple. You will not provide anything here. Just you have to register through the factory and you have to call its constructor default. That's it. And then APB sequence here, it's an object, right? So we will register with the UVM object, all this. So here actually the task body, everything will be there. But for now, I haven't included anything. But inside that body, we have to provide whatever the stimulus in what way. If you have any constraints, all that we have to do it inside the sequence. And inside the APB test is the let's discuss others also. APB transaction is nothing but all the this P address, whatever properties, all this has to be declared here. All the inputs has to be randomized, all the outputs has to be declared, and then what you have to do is if you want to write any constraints, all those you can mention inside this transaction class. So once you are done with the skeletal, if there are no issues with your skeletal code, then you can start implementing the transaction class by taking the reference from the codes which were there in our recording sessions. You can just have a snapshot of it and you can just try building your transaction class related to the APB. You also have the spec, right? You know what signals has to be included for the APB transaction. You can just start implementing. Okay. Once if you are clear with the skeletal, if there are no errors you have done, then you can start doing that. And then APB environment, inside that we have agent scoreboard, all that, right? We have to create and appropriate connections has to be done in the connectors. So for now, we don't need, we haven't done anything related to that. And scoreboard, you can totally, if you don't include that also, it's fine because right now we will not implement the scoreboard logic. We will implement it the later part. So, but still, just you can have the component, whatever, all this you can just register. And this is the run.do script. You just copy paste it in your environment when you do it, because using this only we run our particular code. This is the run.do script file where we are trying to run the particular test case. Here, as we always discuss, right? I think I have told so many number of times, we provide the test case through the command line argument. Otherwise, it will take whatever is there in the run test. This is what I was talking about. And I was also saying instead of dollar display, use the UVM info, all that, right? Because if you want to filter any of the messages using this UVM verbosity, you can give the different you can set the verbosity level, and now it is set as UVM medium. You can change it, and based on that, whichever things you want to be printed, all that. We will have a hands-on session on the UVM verbosity also once after few sessions. For now, you guys just focus on this skeletal coding. I want every one of you to do it at your end in the EDA playground. I will share this link. Don't worry. Taking the reference of this, you do it. Please don't do the copy paste work, because that is not necessary to do a copy paste work. Anyone will do. You need not specifically sit for the session and do copy paste work. Try to do your own things. And if you get any query, you can take the reference of it. If you still want to do the copy paste work, it's up to you. Okay. So the other thing, so once everything is done, how will you make sure that you have created everything, or have you missed anything? For that, you can print the topology. How will you print the topology is inside the APB test. I have something called phase here, end of elaboration phase. Inside that, you can use this method UVM underscore top dot print topology, which is provided by the UVM library itself. So you can directly use it, UVM underscore top dot print topology. Then it will print your entire hierarchy, whatever you have created. So if you feel that anything you have missed, it will be seen here. For example, I have only one agent here, right? If you have two agents also, now it's not just to try to understand, you can create two agents and you can try one more code for that and try to experiment and see if the topology is getting printed or not. See, all these things all up to you, how well you will try and how. So every concept what you have learned so far will be more clear to you when you try by your own, when you try with your own ways in the code. So any doubt you have, will this work, will that work, just try and implement it and see how it is going, how the way it is reacting, what error it's giving. Based on that, you can come to a conclusion saying that okay, this is not working for this reason. So all these things, it's up to you how well you will explore. So for now, we can end the session. But if you have any queries, we'll go through. But I will share this code so that you guys can start coding instead of. There is nothing else to explain. I've explained everything with respect to the skeletal part. So you guys can start coding. If you want, if there are any queries to start, how do I do everything? Then you can ask. I can explain. Otherwise, we can end the session. Is it clear for everyone so far what we have discussed?
Yes.
Okay. So Devika, will you be able to create the skeletal part like this at your end?
Yes, ma'am.
Yeah, okay. What about others?
Clear.
Clear, right? Fine then. So I'll share this EDL link to all of you. You guys can refer this and start skeletal at your end, because it will be easy for you to develop. You need not wait for me. If you are comfortable taking, just take any one of the, at least build a transaction class. If driver is becoming tough for you, that's okay. At least build a transaction class. All those things are creating the ports. At least if ports is also difficult for you guys, at least I'm expecting you guys to complete the skeletal, and after that the transaction class. So these things you just complete it, and we will meet in the next session. If it is very early for you for tomorrow, I will also give 1 day more. You guys can take 1 day more, but just make sure that before our next session, we will be completing the skeletal part. So is 1 day enough for everyone? Okay, someone said 2 days. Let's see, you guys start with it. Then if you really feel 2 days is necessary, we will do it 2 days. Otherwise, we will do it in 1 day. So based on everyone's responses, we will do it.
Ma'am, want 2 days.
Okay, fine. Then let's do it in 2 days. So nothing hurry. But make sure that so far, whatever concepts we have discussed, you are up to those and you work on this also. Okay.
Okay, ma'am.
Yeah. Thank you all.